All right, let's look at section 5.1 problems from the final exam review. I'm just going to do selected ones. So this objective was to find the antiderivative for a polynomial function. All right, so let's go ahead and look at question number 17. All right, so on that one, we were being asked to do the antiderivative for this polynomial. Well, it's not really a polynomial because of the x to the 3 halves, but of this function. Okay. All right. So when we go to do that, since we have pluses and minuses, between stuff, if you just have adding and subtracting, then you can do term by term integration. So I'm going to think about x to the 3 halves, and I'm going to add 1 to that. 3 halves plus 1, 3 halves plus 2 over 2 would be 5 halves. That 5 halves would come down in front when I go to check it. So I need to put a 2/5 here. So when I multiply by 5 halves, that would wind up being equal to 1 and give me what I'm supposed to have. Right? On this one, this is 2x to the first power, really. So I need an x to the second. Okay. And then that 2 would get brought down in front and give me what I want. So if you notice that, just do that. If you prefer having like a set kind of rule that you use, you could add 1 to your exponent, then put a 1/2 here to knock out the 2 when it gets brought down in front. And then there was already a 2, a constant, so we brought that along. And then that'll wind up canceling out because 2 times 1/2 is equal to 1. So we'll get just an x squared there in the middle. And then at the end, we need an x. And we're doing antiderivatives. That's the same as indefinite integration. So be sure you think about that, the fact you could have any constant there at the end. Now, this one had a 3 halves to start with, so I'm not going to rewrite this using radicals, even though it is a radical of some sort, but I am going to do the 2 times 1/2, simplify that. And then this would be my answer. This was number 17. Right? So there's a couple others you can do. And if you do this using the interactive textbook, you can actually click on those little answer boxes and see if you did those correctly. Okay. All right, now let's go ahead and proceed to the next objective, which is to find the antiderivative of let me get it back to slideshow version. And let me go to the next one. Okay. Find the antiderivative of a trig function. All right, so I don't know, let's go ahead and do 25, 27, or 28. Let's go ahead and look at 27. So I'm just picking selected ones to look at. You could do the others. Just go to the e-text and you could work them and then see if you're doing them correctly. Okay, so on this one, we're being asked to find the antiderivative for secant squared theta minus sine theta with respect to theta, d theta. Okay. All right. So again, we have adding or subtracting here. So we can just like integrate each piece of this. And so right now in 5.1, when we first did it, if we're going to integrate a trig function, then what we see has to be the answer of some derivative problem we had done back in chapter 3. And that's exactly the case with secant squared theta. That would come from tangent theta. Okay. So the derivative of tangent is secant squared theta. Okay. All right, now when we go to think about where that sine theta came from, we could think, well, if I do the derivative of cosine, I wind up getting negative sine theta. Oh, and that's what I need. I need a negative sine theta. So I'm going to put a plus here because when the derivative of cosine theta happens, that's where that negative is going to come from. And then I'm going to add a C on that. Okay. All right. And then there's one more objective coming from the 5.1 material, and that's looking for the particular solution of a differential equation that satisfies the initial condition. 37 and 38 were given as example problem numbers. So let's take a look at 38. So here we're being given that g prime of x is 4x squared, and then we know that g of -1 should equal 3. Okay. So what we're going to do is we're going to integrate to get g of x. So we're going to integrate 4x squared with respect to x. Okay. And then that will be g of x. So let's do that work. So to get 4x squared, when I'm finished, I know I needed to add 1 to the exponent. I'm going to bring a 1/3 out in front to knock out that 3 that would be brought down. I'm going to bring the 4 along, that constant along. And then at this point, I really have this plus c. This is the general solution. Okay. So right now I have 4/3 x to the third plus c. My job is to get the particular solution for this differential equation. So what I'm going to do is use this information right here. This information is saying when x is -1, the y-coordinate is 3, and it refers to the g function. So I now have, this is the g function now. Okay. So what I'm going to do is I'm going to plug in the -1 for the x. Make sure you think of it in parentheses like that, plus some constant will have to turn out to be 3. So let's see what that winds up being. I can't move this up like I can with my Word documents. Anyway, okay, so that's going to wind up being 4/3 times a -1. So that's -4/3 plus c is equal to 3. So I'm going to add 4/3 to both sides, and c would equal 4/3 plus 3. And you can do that on your calculator, or that's 4/3 plus 9/3, which would be 13/3. Right? And then you're not really done at that point. You have one more little step to do, and that is to take your g, and right there where c was, you're going to replace it with 13/3. So that would equal 4/3 x to the third plus 13/3. And then that would be your answer on that one. Okay. All right. And that's everything from 5.1.